On February 18th, 2021, Perseverance will complete its 7-month journey to Mars, plunge into the thin atmosphere, hopefully land, and then do some amazing science. If you want to know all about Perseverance's flight and what it will do once it's on Mars, but don't have a ton of time, this video's for you. Hey y'all, it's Dr. Know-It-All. On July 30th, after a number of launch delays, which was kind of scary because there's a really limited window every 26 months when we can launch spacecraft to Mars, NASA managed to launch its Perseverance Rover plus a tag-along helicopter, Ingenuity, to Mars on an Atlas V 541 rocket. So after nearly 7 months en route to Mars, using the Hohmann transfer orbit to minimize propellant usage, Perseverance, which is now attached to a cruise stage craft that provides guidance, power via solar panels, and thrust capability, is fast approaching Mars. I'll be doing a live stream of the landing on Thursday the 18th, so if you happen to watch this before Thursday and you want to catch the live stream, definitely subscribe so you can check that out when the time comes. While Perseverance looks very much like Curiosity, which has been on Mars for about 9 years, this is a very different rover. Plus, it has a Hopper helicopter attached underneath it, which is super cool. By the by, you can actually keep up with Perseverance on Twitter. It's at NASA Persevere on Twitter, and of course, why not? Because everything is on Twitter these days, right? Anyway, Perseverance will join 2 other amazing craft that have just arrived within this conjunction window. The UAE's Hope craft, which is in orbit around Mars, and which will study the atmosphere of Mars. And by the way, this craft is amazing. It was built entirely in-house by the United Arab Emirates, and it will be doing incredible work examining the nature of Mars's atmosphere. And China's Tianwen-1 mission, which is itself 3 craft, an orbiter, a lander, and a rover. So that's all pretty cool stuff. These other 2 projects are amazingly ambitious and complex, and here's hoping Perseverance can make it a successful trifecta. One big difference between Perseverance and the other 2 missions is that Perseverance is not an orbiter, so its arrival is in many ways much more complex than that of the other 2 craft. It will be screaming into Mars without a braking burn. The other 2 craft wanted to get into orbit, so they have done very long braking burns to reduce their speed to orbital velocities. And by the way, if you're interested in orbit and orbital velocities, I recently did a video on that, so you can check that out. Anyway, Perseverance doesn't need to orbit Mars, it just needs to land on Mars. So it's going to hit the atmosphere pretty much at a full fall. So it's not going to break itself into orbit first and then go down, it's just going to come straight into the atmosphere. Of course, using the very, very thin atmosphere of Mars to reduce the craft's speed saves a ton of propellant and allowed the rover to be heavier, but this is all at the cost of them needing to execute the entry, descent, and landing perfectly. This is why NASA calls it the 7 minutes of terror. Ironically enough, the landing is either going to be done or fail long before we even know it started on Earth. Given the distances right now, it's about a 13-minute delay just in getting a signal from Mars, so the landing will be over for more than 6 minutes before we hear the first transmission about the descent itself. By the way, this time the descent is going to be much more interactive than with the Curiosity rover. There's going to be cameras, microphones, an attempt to do some real-time data transmission, etc. So it should be a pretty fun thing to watch, even though, of course, we'll be watching it after it happens. Anyway, as you might expect, because there is such a long light delay, the landing itself is completely automated and no human beings will be interacting with it because it's going to be over before we even know about it. One thing that's super cool about this particular lander is that this time there's going to be terrain relative navigation, which will allow the craft to land in a much more complex and geologically interesting area than previous missions. It's going to land at Jezero Crater, the site of an ancient lake and river delta on Mars. Because of the nature of the geography and geology of the area, this place has many more obstacles than the boring flat plains that previous missions have used due to landing safety issues. Oh, and also one other little note, this craft has 11 million of our names on it, including mine, which is super cool. I signed up way back before it launched. As an interesting side note, the entire profile of the landing is going to happen while the Mars Reconnaissance Orbiter is overhead, so that it can transmit data about the landing to Earth from orbit. Anyway, just a few minutes before atmospheric entry, the cruise stage is going to set up the landing and then eject Perseverance, which will sit inside of an aeroshell to protect it. A few minutes later, the rover inside of an aeroshell will enter the atmosphere, which is only, like I said, 1% as thick as Earth's. So it's really, really poor at slowing craft down, but it exists, so you have to take account of it. At that time, the craft will be traveling about 18,000 kilometers an hour relative to Mars when it hits the atmosphere. During this initial atmospheric entry, the course to the final site will be adjusted as needed by onboard computers via thrusters and/or turning the craft to adjust lift, which, by the way, is super cool, and if you want to see an episode on that, I would be happy to do that. It's really interesting stuff. After about 4 minutes of atmospheric entry, the craft will have slowed down to around 1,000 kilometers an hour, allowing a supersonic parachute to deploy. The supersonic parachute is deployed from the back shell, so there's a heat shield shell which protects it during the initial entry, and then there's a back shell that just keeps it all safe and sound inside, and the parachute will come out of that back shell. As the heat shield is no longer needed at these speeds, shortly after that the heat shield will be ejected via explosives and it will fall away, exposing the rover itself at an altitude of about 10 kilometers. At this point, the instruments on the rover itself will start to collect data and they'll start to look for a good landing target. At about 1 minute and 20 seconds before landing, the rover should have acquired a good target landing site, something flat and devoid of large boulders within the general area. At 1 minute, the back shell with the parachute on it are ejected, and the descent stage, which cradles the rover under it, fires its engines and slows the speed from around 300 kilometers an hour down to just a few meters per second by landing time. At about 13 seconds before landing, at only around 8 kilometers an hour descent speed and around 12 meters off the ground, the rover is lowered on cables below the descent stage. This, by the way, is so that the area is not disturbed by rocket engines blasting straight into the ground. The rover then descends about 6 meters below the descent stage and then is released. And as it's descending, the wheels come out so that it can rest safely on the ground. Then, as the rover touches the ground, the cables that connect it to the descent stage are severed via explosive guillotine, and the descent stage actually blasts off and away so that it's not disturbing anything where the rover is landed. And then the rover and the helicopter that's tucked in under it are on the ground. No sweat, right?
It's too easy. No. So easy.
All right, so now that we know how it lands, what is Perseverance's mission? Well, the cool thing is, its mission is to search for evidence of life. Like I said earlier, Jezero Crater appears to have had a large body of water in it around 3.5 billion years ago. This, of course, is dried up now, obviously, but the craft is going to roam around searching for signs that there was once life in this ancient body of water. So how big is Perseverance and how much does it weigh? Well, it's about the size of a Tesla Model Y. Perseverance is like shorter but also wider and taller, so it's like you took a Model Y and kind of squished it from front to back and it kind of expanded from the side and on the top, so that's more or less the shape. But Perseverance only weighs about half of what a Model Y does. It only weighs just over 1,000 kilograms, which of course is far less than a Model Y, which weighs over 2,000 kilograms. As for lifespan, the rover is designed to work at least one Martian year, which is 687 Earth days. But as you may know from the past missions, these missions often last much longer if things are working well. And here's a little added factoid bonus for you. 7th grader Alexander Mather won a contest to name the rover, so good job, Alexander. And what does Perseverance include on board, and how will this help us look for life on Mars? First, it has a radioisotope thermal generator that will provide power for years to decades via the decay of radioactive particles that's then converted into electricity. This has been used on a number of other Mars missions, and it's far better than solar on Mars. There's no dust, there's no degradation, there's no seasons it has to account for. It just produces electricity and everything's good until the nuclear power source runs out, of course, and then it dies. Perseverance has 7 main instruments on board. It has the Mastcam-Z, which is 2 panoramic 3D cameras with zoom capability. It has the SuperCam, which is a close-up camera that uses lasers to image tiny objects. It has MEDA, or Mars Environmental Dynamics Analyzer, which is a built-in weather station. It has SHERLOC, which is a UV spectrometer with an accompanying camera. It has PIXL, which is an X-ray spectrometer, which is higher energy light than UV light. It has MOXIE, which is a demonstration instrument that will hopefully use the Sabatier process to extract O2 from the Martian atmosphere. And by the way, this demonstration project is huge. If this works, it means we can directly generate oxygen and also methane fuel on Mars. And finally, Perseverance has RIMFAX, which is ground-penetrating radar. And it also has 2 microphones, so we will be able to hear Mars. And apparently they're going to be used during the landing itself, so we'll actually be able to hear the landing when they transmit all the data back, which is going to be super cool. And of course there is Ingenuity, which will be the first craft capable of flying on Mars. This is just going to be a demo instrument. It only weighs about 1 kilogram or so total weight, and it might only fly a few times, but it's going to be amazing nonetheless. Demonstrating that you can fly in an atmosphere that's only 1% as thick as Earth's is going to be a big deal. And of course, if this demo mission works, future missions will go much bigger with flying robots on Mars, so here's hoping it works. So the Mastcam, MEDA, the weather station, MOXIE, and RIMFAX are all amazing, but the real stars of the show this time around are SuperCam, SHERLOC, and PIXL. SuperCam, as you might imagine from the name, can of course provide imaging, but also it can provide chemical composition analysis and mineralogy, and it's designed specifically to detect organic compounds from a distance, which is really interesting. Basically, you shoot the laser at a rock or some other object, you find out what it's made of, and if it has organic compounds in it. Then there's PIXL, Planetary Instrument for X-ray Lithochemistry. So many acronyms and big words that NASA always uses. Anyway, PIXL uses X-ray fluorescence. In other words, you shoot high-energy X-rays at something, and they re-radiate lower-energy photons that tell you about the structure of the object. Thus, PIXL can determine the fine-scale elemental composition of Martian surface materials. And then there's SHERLOC for scanning habitable environments with Raman and luminescence for organics and chemicals. Anyway, SHERLOC has a high-res camera on it, plus a UV laser that can determine fine-scale mineralogy and detect organic compounds as well. So basically, SuperCam can identify good options for study from far away. The rover can then drive over to that object, and without even needing to drill, PIXL and SHERLOC can closely examine the object for composition and, more exciting, for signs of ancient life in the form of organic compounds. And finally, there's a drill cache rig on the rover to collect and set aside the most promising finds for future missions to collect and return to Earth. Or who knows, perhaps maybe someday humans can pick them up on Mars themselves. I find the drill cache system really optimistic for future missions, and that's very exciting. So anyway, that's the compact version of how Perseverance is going to land on Mars, what it has, and what it's going to be doing there. Who knows, in a year from now, we might have evidence that life once existed on the red planet, and that would really change everything we think about our universe. Okay, I hope you enjoyed this episode and found it fun and informative. If you did, definitely like it so other people can find it, and also definitely subscribe, especially if you're interested in watching the live stream of the landing. Also, a big shout out to my Patreon patrons. You all are wonderful. And thanks for this idea, by the way, which came up in a Discord discussion. It was a great idea. We also have a new patron since last time, Glenn Little. Nice to meet you. And of course, don't forget about our merch store, which now has hoodies and plaid. And also remember, if you're in the market for a Tesla and you use our link below and you purchase a Tesla, we each get 1,000 free supercharger miles, which is great. And also, we are Amazon affiliates now, so if you look in the description and you click on the link and you go shopping at Amazon, anything you purchase in the next few hours helps out the channel, and we really appreciate it. Thank you so much. And as always, please feel free to ask me questions in the comments or at my email address, which is drknowitallknows@gmail.com. Till next time, bye-bye.